All right, welcome back to Unit 7 ACT Prep, talking about trigonometry, and today we're going to talk about trigonometric identities. All right, so trig identities, we can use them to find the values of other trig ratios or to rewrite the ratios in equivalent forms. And you really do need to memorize these. All right, your reciprocal identities tell you that secant is reciprocal to cosine. So any of these statements are true. Whenever you see secant theta, you can replace it with 1 over cosine. Or you could say that secant theta times cosine theta is equal to 1. Or you can say that cosine is the reciprocal to secant. Same with cosecant and cotangent. Okay, your quotient identities, these are important. A lot of times this helps us. So you can rewrite tangent as sine over cosine. And you can rewrite cotangent as cosine over sine of the same theta. Your Pythagorean identities are really important. This probably is the most famous. Sine squared theta plus cosine squared theta is equal to 1. Keep in mind, you can use different one of these. For example, if I have sine squared theta plus cosine squared theta equals 1, if I subtract cosine squared theta, I can also say that sine squared theta always equals 1 minus cosine squared of the same angle. Likewise, you could have subtracted the sine squared and you could have said that cosine squared theta is equal to 1 minus sine squared theta. So these three are very important. Whenever you see those, you should think of the Pythagorean identity. Okay, and you can also, if you look at the tangent, there's a similar Pythagorean identity with tangent and secant, and there's another similar one with cotangent and cosecant. And again, you can manipulate these to say anything you want to. You could get tangent squared alone, you could get 1 alone. This one, you could either get cotangent alone or 1 alone. So just keep in mind that they don't always look like this. They might be a different form of this. Your double angle identities, sine of 2 theta, you can rewrite as 2 sine theta times cosine theta. Cosine 2 theta is neat because you have 3 choices. You can either rewrite it as cosine squared minus sine squared, or you can rewrite it as 2 cosine squared minus 1, or you can write it as 1 minus 2 sine squared theta. Okay, and your tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. Okay? All right, and then your half angle identities, sine of half of whatever angle you're looking at would be plus or minus the square root of 1 minus cosine theta over 2. Similarly with cosine and tangent. Okay? All right, so it says the sine of theta is the square root of 3/4. What is the cosine of theta? Now, you can do this a couple different ways, but what I would recommend is using this identity. So if we say, if we say sine squared theta plus cosine squared theta equals 1, then I can plug in, they gave me the sine. So if I square it, that would be the square root of 3/4 squared plus cosine squared theta equals 1. If I square my square root function, the square kills the square root and I'm left with 3/4 plus cosine squared theta equals 1 minus 3/4 minus 3/4, I get cosine squared theta equals 1/4. And just type it in the calculator, do 1 minus 3/4 and math enter it, or 1 is easy to make. This 1 is the same thing as 4 over 4, and 4 over 4 take away 3 over 4 is 1 over 4. They don't want cosine squared, they want cosine, so I need to kill the square root, and when you square root a fraction, you square at the top and the bottom. So this would be cosine theta, which is what I want, would be 1/2. And there you go. Okay. All right, this one, it says the secant of theta is 5 over the square root of 5, and they want to know what the sine is. Well, if I know that the secant of theta is 5 over the square root of 5, secant is reciprocal to cosine, So I can say then cosine theta equals the square root of 5 over 5. And now, since they want sine, I can use my Pythagorean identity again, and I can say sine squared theta plus cosine of theta squared has to equal 1. So we simplify similar like we did last time, and this will give me sine squared theta plus 5 over 25 equals 1. To get sine alone, I'm going to subtract 5/25, and I get sine squared theta equals, again, this would be 25 over 25. Take away 5 over 25 would be 20 over 25. And then I have to square root top and bottom, so I have sine theta equals the square root of 20 over 5. Okay, but again, that's not, I mean, we're not wrong, but anytime that a radical can be simplified, we got to try. So break 20 down. By 2 is 10, by 2 is 5. There's a 4, square root of 4 is 2, square roots of 5. So sine theta is equal to 2 square roots of 5 over 5. And we're done. Okay. Alright, this one says demonstrate that 2 times 1 minus sine squared theta minus 1 is equal to cosine 2 theta. Your technique for these, anytime they're trying to say demonstrate that this side is equal to this side, you pick a side and you simplify it. I'm going to pick the more complicated side, and I'm going to try and see if I can reduce or simplify it down to look like cosine 2 theta. So I'm looking at my different trig identities, and I know I've seen something like this before. Anytime you see sine squared, anytime you see squared, go to your Pythagorean identities and see what you got. Well, I don't have 1 minus sine squared anywhere, but I've got a formula that has 1 and sine squared in it, so maybe I can make it look like that. And if I take sine squared theta plus cosine squared theta equals 1, and I'm trying to get 1 minus sine squared, so I can do that if I subtract sine squared off, and that gives me cosine squared theta equals 1 minus sine squared theta, which means I can replace this, not the 2, not the minus 1, but I can replace 1 minus cosine or sine squared with cosine squared theta. Okay, so now if I simplify that, I distribute, I get 2 cosine squared theta minus 1. Well, I'm like, well, how do I make this look like this? Well, I'm going to look at, anytime I see it multiplied by 2, I think double angle. So I'm seeing if I can find anywhere where it says 2 cosine squared theta minus 1. Oh, look, right there. And that is equal to cosine 2 theta. So I have proven that this does indeed simplify down to this. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got cosine 2 theta. Okay, these are, yeah, they're hard at first. When I first started learning trig identities, it was real difficult for me. And the only thing I can tell you is that the more you see them worked out, the more you kind of learn where to look. I wish there was an easier way, but you know what I mean? You've got to somehow memorize those identities and get them in your head, and the more you look at them trying to simplify these things, the better you learn them, and then the more they stick out in your brain. Anyway, what I looked at was if I have a sine of something on top and I've got it over tangent, I always think, well, tangent has a sine in it. So if I can rewrite tangent with sine, and I can with the quotient identity, I might be able to get something to cancel out there. Okay, so the first thing I did was here's the thing though. When I rewrite my tangent, it's going to be in sine theta over cosine theta, not 2 theta. So I'm thinking I'm going to have to rewrite both of these. And oh look, I can rewrite sine with just a sine theta here instead of 2 theta, which will cancel out with something in that. I don't really know where I'm going to end up, but it's the first thing I thought of was I can make some sines cancel with tangents because sine is in tangent. Okay, so I'm going to rewrite sine 2 theta as 2 sine theta times cosine theta. On bottom, I'm going to rewrite tangent as sine theta over cosine theta, and that's all minus 1. Okay, so now if I simplify this fraction and I keep, change, flip, I have 2 sine theta cosine theta times cosine theta over sine theta minus 1. Well, now that I keep, change, flip, this sine squared will kill this sine squared, and that leaves me with 2 cosine squared theta minus 1. Okay, once I got there, I'm looking for, I see a 2, so I'm going to go look at my double angle identities and see if I can find 2 cosine squared theta minus 1. Bingo, there it is. So that's equal to cosine of 2 theta. Okay, and like I said, don't feel bad like there's no way I would have gotten that. Neither would have I when I first started trig identities. You have to just watch them worked out a few times where you kind of get the gist of how do you rewrite things to make certain things happen. And I'm sorry, it's just experience. You just got to kind of play with these until you kind of learn some tricks of, and the more you do it, the more you learn how to, oh, I know that tangent has sine in it, that's got a sine in it, so somehow I can make something, you know what I mean? You just kind of have to play with these a while. Alright, try this one. Hit pause, come back when you're ready. Okay, now on this one, as far as an ACT prep question, okay, I'm going to work it out and I'm going to go through every single F, G, H, J, and K. But obviously, in a real ACT test, you would not have the time to do this. What I would recommend is you look at the ones you can just see. Okay, so let's see. There is no cosine squared half angle. The secant squared minus tangent squared. Like again, if I was approaching this for a real ACT, I'm going to try and eliminate the ones that I can see first. So if I'm trying to find the one that's false, okay, I'm going to look real quick at the ones that are easy. Pythagoreans are pretty easy to figure out. So I'm going to see if this is true. The Pythagorean identity for this says 1 plus tan squared equals secant squared. Well, if I add tan squared theta, is that true? Does secant squared theta equal 1 plus tangent squared? And yes, it does. So that's true. This looks like a nightmare because I'm going to have to FOIL that all out. Okay, so I ain't going to try and see if that one's true or not. Same with this one. You got your double angles and minuses and all that. So I'm going to look at this bottom one because I do have cosine of my double angles. So I come up here and I go cosine 2 theta. I have 3 choices. It either equals this, which is not what they wrote, or it equals this, which is not what they wrote, or it equals this, which is not what they wrote. So there's no way cosine 2 theta equals this. So this would be my false one and I would be done. Okay? Now, just for your experience, so that's how I would approach it. I wouldn't attempt to try and see if this one's false or not because it's going to be way too long. Same with this one. I'm going to have to do a lot of substituting and a lot of math to figure out if this one's true. So when you get to them and go, oh, right now that's too much work. That one was easy to prove was true. A lot of work, a lot of work. This one looked kind of easy to see quickly, and sure enough, that was the one. Okay? Now, I'm going to work out the rest of them just because it's going to be good for you to see these proofs. But again, in a real ACT test, you would not have time to work all of these out. Okay, but I'm going to prove them to you, okay? So for F, what I noticed was, well, it's something to do with a half angle, okay? Well, my half angles are not squared. So what I noticed is, well, it's this one, or trying to be this one. So if I squared both sides, what would happen? Well, this would give me cosine squared. That would give me this. And if I square this square root, that would cancel, and it would be that. So that is true. Okay, that one wasn't too bad. Now h, all right, you're going to have to FOIL it out. So I would have, this is for h, I would have cosecant squared theta times sine, wow, did you read that? Sorry, I'm going to try and write when you can read it. Cosecant squared theta times sine squared theta. And I'm going to do these in different colors so it'll be easier for you to see me simplify them. The next one would be plus cosecant squared theta times cosine squared theta. My next would be negative cotangent squared theta times sine squared theta. And then my last would be, I need a different color, how about green, would be a negative cotangent squared theta times cosine squared theta. Okay, so now we would have to simplify all of these. Well, I know that cosecant is reciprocal to sine, so I can rewrite this as 1 over sine squared theta times sine squared theta would cancel out, and so this whole thing would simplify down to magic 1. Oops. Alright, my next one, alright, would simplify down to, again, this would be 1 over sine squared theta times cosine squared theta would be cosine squared theta over sine squared theta, which would be, if you go over here, cosine over sine is cotangent. So this simplifies down to cotangent squared theta. So now I have 1 plus cotangent squared theta. My red product, cotangent squared down here, is cosine squared theta over sine squared theta times sine squared theta, cancels out, so this just gives me negative cotangent squared theta. Yes, and then my green, I'm going to leave it written as, again, cotangent I can rewrite as cosine squared theta over sine squared theta times cosine squared theta. I could multiply that and get cosine to the 4th theta, but those aren't going to help me. So I'm going to just leave that written as minus cosine squared theta over sine squared theta times cosine squared theta. Okay, so now I got to do some interesting things here. So the first thing I notice, I'm trying to figure out if I can rearrange these somehow. Well, the first thing I notice is that my, oh, that's not cotangent, that's cosine. My bad. Hold on. Is that cosine? Yeah. Sorry. I screwed that up. That's cosine squared theta. Okay. So the one thing I noticed is that if I put these two together, let me change my color there. I recognize the Pythagorean identity, and if I put 1 minus cosine squared theta together, I come up here, if I subtract a cosine off, 1 minus cosine squared is equal to sine squared theta. Okay, and then I'm going to put these two together, so that would be plus cotangent squared theta minus, okay, I'm just going to leave this cotangent. Cotangent squared theta times cosine squared theta. Because now, on the last two, I can factor out a cotangent squared theta. If I divide by cotangent squared theta and cotangent squared theta, that cancels and gives me 1. That cancels and gives me minus cosine squared theta. Well, again, that 1 minus cosine squared theta, cosine squared theta plus this is sine squared theta. So I have cotangent squared theta times sine squared theta. Well, now I can factor out the sine squared theta, which if I divide by sine squared theta, divide by sine squared theta, I get 1 plus cotangent squared theta. Alright, and then if I look at my Pythagorean identity with cotangent in it, 1 plus cotangent is cosecant squared. So I have sine squared theta times cosecant squared theta. Well, now cosecant is reciprocal to sine, so I can say sine squared theta times 1. Oh no, cosecant is 1 over sine squared theta. Those cancel, and sure enough, I get 1, so it's true. But do you see what I mean about how long that took? Okay, that's way more than a minute just to prove one of them was true. It wasn't even the one I was trying to find. Okay, so like I said, go through and try and see what easy ones you can figure out, and then if that doesn't lead you anywhere, then you're going to have to do the others. But that one came out true. So what do we have left? J, this one? Okay, well, I see tan 2 theta minus tan 2 theta tan squared theta equals 2 tan theta. Well, again, I'm just going to work on this side, and I see that they both have a tan 2 theta. So I'm going to do tan 2 theta. I'm going to factor that out, which would leave 1 minus tan squared theta. Well, 1 minus, if I rewrite the double angle, so if I go up here and I rewrite tangent 2 theta as 2 tan theta over 1 minus tan squared theta, and I'm multiplying by 1 minus tan squared theta, those cancel, and I end up with 2 tan theta, which is what I was supposed to end up with, so that is true. Okay? And again, like I said, once you found the false one, I wouldn't have worked the rest of them out. But again, to show you some experience, give you some experience of how you approach these and prove whether they're true or false, well, that's kind of the proof for H. And like you can see, it's long. Alright, so next it says if cosine of theta equals the square root of 3 over 2, find the sine of theta using trig identities. Again, anytime they give you cosine and they want you to find sine, you're using sine squared theta plus cosine squared theta equals 1. Alright. So I'm going to have sine squared theta. I know what cosine theta is, so the square root of 3 over 2 squared would be cosine squared theta, has to equal 1. So I have sine squared theta plus 3 over 4 equals 1. So I'm going to minus 3/4. And that gives me sine squared theta equals, again, this would be 4/4. Take away 3/4 would be 1/4. Square root. And I get sine theta equals 1/2. Okay? 2. If cosecant theta equals square root of 2, find the cosine. Well, again, they want me to find cosine. This isn't sine, but it's reciprocal to sine. So again, told you that one was most common. So if cosecant theta equals the square root of 2, then sine theta, flip it, is 1 over the square root of 2. So now when I do sine squared theta plus cosine squared theta equals 1, I can say that sine squared theta is 1 over the square root of 2 squared plus cosine squared theta equals 1. That is going to give me 1 over 2 plus cosine squared theta equals 1. Excuse me, subtract 1/2, subtract 1/2, and I get, sorry about I'm going kind of backwards, I get cosine squared theta equals 1/2. 1 minus 1/2 is 1/2. Square root, and I get cosine theta equals 1 over the square root of 2. Which is fine, except for I can't leave a radical in the denominator, so rationalize, multiply the top and the bottom by the square root of 2, and I finally get cosine theta equals the square root of 2 over 2. Okay? Alright, so this one says, figure out what these things equal. Well, again, I know that I've got a cotangent here and a tangent here. Well, if I look at my reciprocal identities, 1 over tangent is equal to cotangent. So I can replace this with cotangent theta times cotangent theta plus 1 equals, we don't know. So this becomes cotangent squared theta plus 1. This reminds me of a Pythagorean identity, and I'm looking for cotangent, and oh, there it is. Cotangent squared plus 1 is equal to cosecant squared theta, and we're done. Alright, on this number 4, I'm going to distribute the cosine through, so I would have cosine theta times negative sine squared theta over cosine theta plus cosine squared theta. And I'm trying to figure out what that equals. Well, these cosines cancel, so I have negative sine squared theta plus cosine squared theta. Well, if you write that, that would be the same thing as cosine squared theta minus sine squared theta. And no, that doesn't equal 1. If it was plus, it would. So I'm thinking, where am I going to look for that? Well, I'm thinking double angle. Alright? So I've got cosine squared minus sine squared. There it is. Cosine squared minus sine squared. So it's equal to cosine of 2 theta. And we're done. Okay? Alright, number 5. Oh, I see those square roots and I think half angles. So I'm looking for the square root, plus or minus square root of 1 plus cosine theta over 2. So this is equal to cosine of, well, I almost screwed up. The only problem thing here is that's a 2 theta and that's just a theta. Well, look, this has to match this. So if I put 2 theta in here, then I have to put 2 theta up there. Okay, which the 2's would cancel, so this actually just comes out to cosine theta. Okay. All right, on this one, I started foiling, and it was like getting to be a real mess, and I was like, maybe those are equal to something. So I looked in my double angle identities. Well, I looked at all my identities, but I looked in all of them, and when I looked at my double angles, I found them. If you have 2 cosine squared theta minus 1, that's equal to cosine 2 theta. And then I'm looking, and I got 1 minus 2 sine squared 2, which is this one. So that also equals cosine of 2 theta. Okay, that's going to give me cosine squared of 2 theta. And there you go. Okay. Alright, number 7. Anytime I see sine over cosine or cosine over sine, I think of tan or cotan. And sine over cosine is tan, so sine squared over cosine squared is tan squared over a theta plus 1. Well, anytime I get a square, I think of my Pythagorean identities. And tangent squared plus 1 is equal to secant squared theta. Done. Alright, 8 is super easy. Pythagorean identity, numero uno. Sine squared plus cosine squared is 1, and pi times 1 is 5. Okay. Number 9, you have 1 minus cosine theta over 1 plus cosine theta. Alright, so I'm looking and I see something like that, but it's under a radical. Well, if I wanted that outside of the radical, I would square both sides. That would kill it, which would give me exactly what I want. So square this side would give me tan squared of theta over 2. Done. Okay, number 10, I got secant squared. This reminds me of Pythagorean identity. 1 plus tan squared is secant squared, so that would give me secant squared theta over secant squared theta, which is just 1. Okay. Alright, you try this one, hit pause, come back when you're ready. Alright, and hopefully you got C. Alright, I see 1 divided by 1 plus tan squared over secant. So the first thing I do is I'm going to rewrite this 1 plus tan squared with secant squared. So that would be 1 over secant squared theta over secant theta times 2 sine theta. Alright, well on bottom there, this 1 copy of secant will cancel 1 copy of secant there. Well, 1 over secant is cosine. So this turns into cosine theta times 2 sine theta gives me, and if you look, that would give me, look here, oh look, 2 times sine theta times cosine theta. I'm in the wrong order, but you can multiply in any order you want. I can rewrite that as 2 times sine theta times cosine theta, which equals sine of 2 theta. Okay? Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got 1. Okay, I see a double angle identity, so I go to my double angle, and I'm going to rewrite the top with 2 sine theta cosine theta, and that's over 2 cosine theta, times sine theta plus cosine squared theta. Okay, oops, sorry. So on this one, I can cancel out the 2's and the cosine theta, which leaves me sine theta times sine theta is sine squared theta plus cosine squared theta, which is my most famous Pythagorean identity of all, which equals 1. Yeah? Cool beats. Alright, try this one. Hit pause. Come back when you're ready. And again, on this one, I would try and look for, because when you're trying to find which one is false, that means you've got to look and see which ones are true. Alright, so again, I would look for some obvious ones. I'm going to work them all out for you just to give you the experience of working with these trig identities. But again, in an ACT type situation where you're trying to do a problem in a minute, these can get pretty lengthy. Alright, so if I start with A, okay, if I do sine squared plus cosine squared, that's 1. Cosecant squared minus cotangent squared. Well, I'm going to look at my Pythagorean identities. Cotangent and cosecant is this one. It doesn't look like that, but could I make it look like that? Well, if I minus cotan squared, I get 1 equals cosecant minus cotan squared. So this also equals 1, which is true. Excuse me. Alright, on B, it says cosine squared theta minus sine squared theta. I've seen that before. Oh, yeah, right there. So this is equal to cosine 2 theta. On this side, I have cosine squared theta plus sine squared theta, which we know is 1. Well, cosine of 2 theta does not equal 1, so there's your false statement, and you're done. There's no way, I mean, once you found it, there's no way I would keep going in a real ACT type situation, because you don't have time. But again, I'm going to work out the rest of them just so that you see, get some experience with working with these identities. So as far as C goes, 2 cosine squared theta minus 1. Again, if you look at that, 2 cosine squared theta, that's equal to cosine 2 theta. So this is cosine 2 theta, just on that side. Alright, and 1 minus 2 sine squared is also cosine 2 theta. So that's true. That one was pretty easy to determine. Okay, D, secant squared theta minus 1. Again, if I minus 1, I get secant squared theta equals tan squared. So this would be tan squared theta, which would cancel out with there, which you would get 1 equals 1, which is true. Okay, so now for E, I've got secant squared minus cosecant squared equals tan squared minus cotan squared. Well, what I did was I said, let's see, let me erase this where I have. So I've got secant and cosecant. Those aren't related to each other. Neither are tangent and cotangent. So if I could put secant squared on the same side with tan squared and cosecant on the same side with cotan, I might get somewhere. So if I'm going to, what I'm going to do is I'm going to move this way, and I'm going to move this way. So that would give me secant squared theta minus tan squared theta minus tan squared, right? And then I would add cosecant squared and add cosecant squared. So that would give me cosecant squared theta minus cotangent squared theta. Now I can work. So if I minus tan squared, I get this side is equal to 1. And for these two, if I do cosecant and minus cotan, I get 1. And 1 is equal to 1. So that is also true. These ones weren't too bad. Okay, didn't take a whole lot. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got, come on, J. Alright, well again, anytime you see the famous sine squared plus cosine squared, you can replace it with 1. So I have 1 over cosecant squared. Well, if you have 1 over cosecant, you have sine. So if you have 1 over cosecant squared, you have sine squared theta. And then I have 1 minus sine squared. So if I minus sine squared, 1 minus sine squared is cosine squared theta. Okay? Alright, try this one. Hit pause. Come back when you're ready. Alright, and I'm going to distribute this negative, so that gives me 2 cosine squared theta minus 1 plus 2 sine squared theta. Well, if I put my sine squareds in my combined like terms, okay, I would have 2 sine squared theta plus 2 cosine squared theta minus 2. Factor out the 2 here, that leaves sine squared theta plus cosine squared theta minus 2. This is 1. So 2 times 1 is 2, minus 2 is 0. And that was fun with identities, weren't they? I know that they're very frustrating, guys. Like I said, you just have to, and you think it's a waste of your time, but it's not. Just keep replaying these ones. Okay, and try and do it again without watching me, and then when you get stuck, watch it again. I do this about 10 times. They're gonna pick pretty similar proofs and things like that, okay, to deal with these identities. So get the practice of finding them and substituting. Alright, but I will see you next time for day 3.